%80 of the success in new product development activity lies in the process that we follow while developing the product. In fact, the process that we follow is more important than the product that we are going to develop at the end. In previous video, we had discussed about 4 important stages of new product development with an example of dual voltage power supply. In this video, I'm going to discuss about the 3 another important steps, which are nothing but schematic design, PCB layout design, and also validation of symbols and footprints. Hello everyone, I'm Vaibhav Sugandhi, passionate PCB designer and technology startup founder. Welcome back to our course on PCB designing for absolute beginners 2022. I believe you have watched our previous video. If not, click on the I button here and do watch that video before watching this one. If you like our educational content, then help us to reach more people by sharing these videos with your friends and colleagues. I hope these content are helping you to create a new product in your domain with the PCB designing technology that we are discussing. Alright, I believe that you are able to see my screen right now, and as we discussed in our previous tutorial, we are taking an example of typical application from the data sheet that we referred. So 7805 and 7905 is 2 different regulators which we are using in this particular example. In fact, I discussed about 7805 and 7812 as a reference circuit when we are discussing about the data sheet and all those things. I'm going to design that particular circuit only, but this is taken as a reference circuit. That is where the important part comes into the picture. I want you to know about the reference circuit or the reference circuit diagram that is available in the internet. If you are searching for the circuit that exactly what you are looking for, then it is just not possible to find it on the internet. If it is available on the internet, then everybody would have become a PCB designer, right? So that's why it is not possible to identify the exact circuit that you are expecting. Instead, you will find the bits and pieces of your expectation in each and every circuit that you can find on the internet. So how do you combine that knowledge into one circuit diagram and create your own circuit, which is all about the schematic, is the purpose of this particular video. That's why you can see that this dual voltage power supply is having 2 different voltages, which is one is a positive voltage regulator, another one is a negative voltage regulator, and we are going to use this particular circuit as a reference. Along with that, in the previous tutorial, I have given you one brief circuit diagram in the PPT, which is all about the single voltage power supply, which we discussed already. Now what I'm going to do is I'm going to create a new circuit using these 2 references with my knowledge by referring the data sheet. And I believe that you are going to understand it and you are going to design it by yourself. Let's get started on that. Alright, now you can see that I have placed all the components on the schematic canvas for starting with the schematic design. Notice I have selected the component very specifically. As I already said, we are connecting a transformer with a 12-0-12 3-pole transformer, but we are adding a 12 and 12 volt together to make it as a 24 and 0 voltage reference. That's why I'm using only 2-pin connector here. And after that, I'm having a bridge rectifier. Now you can notice that actually I have added a capacitor filter, and by practice we go with a 1000 microfarad 35 volt capacitor after this bridge rectifier, because the input voltage is 24 volt, and typically we go with double of the input voltage, which is 50 volt on an approximation right now. But instead of going with a 50 volt, which is very bulkier capacitor, instead of that I'll go with a 35 volt capacitor, which is sufficient enough. And this is all about the input capacitor, and then we will be having a 7812 regulator, and then we will be having a 7805 regulator. Both are two different voltages, positive voltage regulator, and then the output capacitor for both the capacitor, 7805 and 7812 regulator will be somewhere around 100 microfarad. 25 volt is sufficient enough for a 12 volt regulator, and for 5 volt regulator it is going to be somewhere around 10 volt or 16 volt is sufficient. If you want, you can go with a 25 volt here also. That is good enough only. There is no problem. It is easy to procure the component because both are having the same rating and all. So I'll go with the same rating and all, and then we will be having a output resistor for 12 voltage. I'll go with probably 1 kilo ohm resistance is sufficient enough for 12 volt output voltage. For 5 volt output, I'll go with a 560 ohm resistance. That's why we'll write it as a 560 R. R represents ohm, because in our keyboard we don't have ohm symbol to type in. That's why in ESDM tool or in EDA tool we use E or R as a representation of ohm in resistance value representation. And thereafter we will be having a 2-pin connector here for 5 volt and 12 volt output. So all things are set together now. The only thing left is routing. Not routing actually, it's the only thing left is all about connection. So let me start with a connection very quickly. Now you can notice that the circuit diagram is ready as a schematic in front of you. And very important thing which you must understand here is I'm using a symbolical representation of a ground symbol rather than connecting a wire from one point to another point. That is a good practice actually. In fact, when you are designing a very complex circuits and all, it is essential for you to understand how to utilize the symbolical representation more often than just dragging a wire from one point to another point, which is a smarter way, as well as it will reduce the complexity, and it is easy for understand for others if you are giving this circuit for a reference or maybe for evaluation. So that's why I'm using a ground symbolical representation in most of the cases when I wanted to add a ground pin or ground connection to any of the components cup in. Now what we need to do is we are ready with our schematic design. I just need to adjust the margin and make the canvas look beautiful and make it professionally looking, and then we head towards the next activity. What I will do, I'll select the border of this entire canvas and I'll reduce the size. Again, as I already said in the previous tutorial, it is a random activity. There is no specific formula for this one. By practice, you will get to know how much to enter, how much not to enter by doing it again and again. But as of now, I don't have any specific formula for you to give to get the exact value, in fact. Okay, so now I got this particular setting here, which is somewhere around 450 by 650 is the size of our schematic. Now I'll change the canvas by hitting a home key on my keyboard and getting the canvas at this origin. Okay, so now you can see that the circuit is ready. Of course, we need to add a text information on the top side here just to indicate what kind of a circuit it is. And of course we need to make sure that it is visibly good also. So I'm going to change the little bit of settings here. Might looks better or may not be looking better. I really don't know. This particular part comes into the picture, or it will make a significant difference when you are designing a segmented circuit, like modular wise. If you are designing a 5 volt power supply one side and 3.3 volt power supply one side and 12 volt power supply one side, and the entire modular architecture is a part of one particular product, on that time this kind of a naming and all those sectioning, all those things will make a lot of difference. But since this is a very simple circuit, which is just a dual voltage positive voltage regulator power supply, so I really don't think so this name will make a lot of difference. However, we will be keeping that name here only for our reference. And I'll just cross verify everything is right or wrong. So it looks like everything is right, and I'll save the file. Of course, saving the file is very important, and this one is for your reference. You can take a screenshot of this one, or you can pause the video and start designing your circuit by yourself. If you have any doubts, of course you can comment me below and ask me question related to schematic design activity. Now let us talk about the footprint assignment and the symbol selection and all. Of course, you must understand here the polarity of the component should be taken care in the schematic itself. For example, if you go to this bridge rectifier, which is 2W10 part number, you must understand the AC pin should be here only. The AC should be connected to this point, and another AC point should be connected to this point. DC ground should be at this point, and the DC output should be at this point. So you must understand this particular activity before creating your circuit. Why? Because it's a polarity activity. So symbolical verification, symbolical arrangement should be done before doing the schematic activity. However, now we are done with the schematic, so if you want, you can cross verify your circuit once again whether the capacitors are connected in a proper polarity or not, or these bridge rectifiers or the bridge rectifier and also these regulators are connected in a proper fashion or not. All those things you can take care and you can verify by yourself by looking at the symbol and the data sheet. Of course, as I already said, the data sheets are the horoscope of every electronic component. So I believe if you have studied the data sheet, it is quite easy for you to understand whether it is right one or wrong one by looking at it only. So just check with that. If you have studied the data sheet, it is quite easy for you to validate the symbols. Once you are done with the analysis of a symbol or cross verifying the symbol, now the time is to go for the footprint activity. How do we do that? Of course, we are going to select the component and click on the footprint option here, and you can see that the footprint will pop up in front of you. I believe whatever the component we have selected, they are very generic one and very specific to that particular circuit. So I don't think so we need to validate the or change the footprint. Of course we need to validate, but we necessarily not need to update the new footprint or create our own footprint, because these components are very popular and available in the global library very easily. So this connector is having a 5.08 pitch, which is absolutely perfect. That is what we wanted. And then we will go with the bridge rectifier. As I already said, while selecting only, we had selected the right component with the right footprint, so there is no need to change the footprint of that also. 1000 microfarad 35 volt capacitor. I believe that we can change this capacitor ka diameter footprint a little bit better one, because I don't think so this capacitor is suitable with 1000 microfarad and 35 volt dimension or that particular value. So instead of 8 mm diameter, I'll go with a 10 mm diameter, which is having a pitch between two lids as 5 mm. So I'll just apply this one, and now let's see what is the pitch, which is 5.08 mm. That's amazing. That is what we wanted. And of course, 100 microfarad capacitors, both are having a 8 mm diameter, which is absolutely fine. And then 7805, 7812, both are having a TO220 package. Again, these are absolutely fine. And now resistors, both resistors are having a through hole technology, which we are discussing as a through hole technology. So RXCL 0.3 is a 0.3 inch is a dimension, the distance between one pin to another pin. which is absolutely common with respect to the components available in the market. Quarter watt resistors, whatever we are using, 0.3 RXCL 0.3 is the selection. And LED, of course, I again, while selecting the component only, I have selected them in a proper way so that I need not to change anything while shifting from schematic to layout. That is a good practice in fact. But sometime what happens, you are not sure about the footprint in the design phase. On that time you will be selecting a symbol, just alone the symbol. Thereafter you are creating your own footprint or maybe assigning any other footprint in the later part. So possible, any combination and permutation combination is possible. However, right now, very simple circuit, that's why we do not need to change any footprint. And LED symbol also very good, and also the footprint is absolutely perfect one. And output connectors, as I already said, they are also good one. I'm preferring to go with a screw terminal here rather than going with a Berg stick, because I'm very interested to make it as a product look rather than just making it a hobby project. Okay, so these are the components, and this is all about the footprint validation or footprint verification with respect to the symbol identified in the entire schematic activity. Now what is the next step? Of course, we need to head towards the PCB layout activity. How we can do that? We can go to the design and click on the convert schematic to PCB. The moment when we click on that, the one pop-up window appears to you, as I already discussed in first video, which is related to PCB designing. So you can just input the 0,0 here and random value here just for starting with. Later on we'll change it as per our requirement, but in the initial stage I'll be doing it, and I'll keeping all the component this side. And now the next process is all about saving the file first of all, because we want that file to be interlinked with the schematic that we have designed. So if it is interlinked, it is quite easy for you to roll back, like identify which component is which one, rather than identifying with the designator and all, which is very brainly activity. Rather than that, I'll just select the component, I'll go to the PCB layout, and that particular component is highlighted, and you can drag and drop it very easily. So this is very helpful when you are designing very complex circuit where there are more than hundreds of components. But right now we have, what are the number of components we have? 8 to 9 components max to max. I guess we have 13 components. Okay, so 13 components is very less number compared to the hundreds of components that we have designed in the early stage and all those things. So that's why it's quite important feature which is applicable in the long run. Right now you can also use that and have a practice of that one, which will help you to keep that knowledge in your handy, so that whenever it is required you can use that particular skill to speed up your activity. Now what I need to do is I need to place the component properly. Again, I'm going to use IPC standard here rather than just going ahead with placing the component to complete the project. Instead of that, I'll go with the IPC standard. What does that IPC standard says? There are so many information related to IPC standard to be studied, but I'm going to talk about the only few things which are essential for us to discuss. I'm going to change the bridge rectifier ka orientation in a little bit customized fashion. Like instead of going with a 90 degree, I'll go with a 45 degree, which helps me to connect these two particular leads directly to the connector very easily. So that's why I'm going to keep it like this, or maybe I'll keep it like this and I'll rotate this particular component. But again, these two lines, whatever we have here, indicate the backside of the connector. If I place it like this, this is not going to work properly, because this is not the right way to place it. Instead of that, I'll place it like this only. I'll interchange something in the schematic diagram. What I will do, instead of making it as a 2-1, I'll shift it, or I'll mirror this particular component. Select it and mirror it somewhere here, without changing any circuit, without changing any footprint, without worrying about the assigning the component footprint part with the specific number and all. I'll just change it in the schematic like that way, the flipping of the component, and I'll import the selected changes in this particular PCB layout, and voila, you can see that the problem is resolved. Okay, so I'll place this bridge rectifier here, and I'll place the capacitor somewhere here. This is looks better to me. Of course, there are so many pros and cons with placing the capacitor like this and like that way. However, it is your choice. You can go ahead with whatever the choice that suits best to you. Keep your creativity flowing so that you can use whatever best possible that you can use in the activity. I'll close the reference circuit. I'll go with our circuit only. Now I have a 7812 and 7805. So let's select those particular component. This is 7805 and this is 7812. I'll be placing the 7812 somewhere here, and then I'll be placing a 7805 somewhere here. Again, notice I'm keeping a sufficient space between both the regulators for the heatsink activity. If you want to add a heatsink for 7805, then you must be able to add it, and if you want to add a heatsink for 7812, you must be able to add it. Both could be possible by using and by placing the component somewhere like this, extreme edges, I believe. Okay, so by placing like this, you can do both the activity. You can place the heatsink here and you can place the heatsink here as well. That is what the IPC standard is all about, which we discussed in the previous tutorial. Now I'll come back here and I'll select the C3. Of course, C3 is 7805, so I'll just select it and I'm placing it somewhere here, straightforward. And then C2 is going to help us here, so I'm going to place it somewhere here like this. Wonderful. And then what we are going to do is we are going to select the resistors R1 and LED1. So let me select that. Great. So this is a 12 volt indicator, so I'll just add a resistor somewhere here and LED somewhere. I think we can add LED little bit outside so that we can visualize both the output at the same point. Let me try how best we can do it. I'm not sure whether this is best possible or not, but I'm just giving a try. There is no hard and fast rule that you have to do it like this only. I'm just giving a try here. Now you can notice again the 5 volt P3 connector is having a problem with the crisscross actually, right? So this blue color rat lines are indicating that it should not be placed like this. You have to flip it. Instead of flipping it, what I will be doing is I'm going to schematic and I'm going to change this one and I'm going to mirror it here. So by doing so, you can see that it's quite easy for us to do the routing activity in our PCB layout. This is where the professional skills comes into the picture. Okay, now you can see that the entire component or the entire circuit is placed in a proper way that is best possible in this tutorial. Now you can see that this part can be a little bit made it a little bit middle so that it looks symmetric and product looks very well. Okay, now I'll drag all these components at the top level a little bit upside so that we can match the distance of the entire board that we have drawn so far. And of course I'll change the board update and all those things in the later stage, but I'm just checking with that 50 and 70. So this one is 70, this one is 50. We can make it as a 25 or 30, but after routing we'll look into it. Now the time is to go ahead with the routing activity. I'll do it in a fast forward. I'll not explain anything because it is already explained in the previous tutorial, and I believe that you have watched those videos and you are capable enough to do that routing activity by just looking at the way I'm doing the routing. Alright, now you can see that the entire routing activity is completed. I hope you remember the reason why I have taken this particular path from the capacitor itself rather than taking it from directly to this point to this point. Okay, that is where the electrical knowledge or the IPC standard comes into the picture. Instead of IPC standard, I would like to say it as a basics of electronics. So I hope you have watched it in previous video and you understood the reason behind it. Now what we need to do is, instead of creating a track for all the ground path, whatever the ground wire we need to connect here, I'll go ahead with the pouring the ground and reducing the PCB size and making it much easier for everyone to make it very easily, because creating a ground path is very complicated in this particular scenario. So I'll just go ahead with that. There is one particular part is missing here, so I'll just draw it and I'll finish the circuit. And once we go to the component library or the design manager, you can see that all the connections are done. Only left part is the ground one. Now what I will do, I'll just come to reduce the size of the PCB. I'll go to the set board info, and instead of 50 I'll go with a 30. That is just my prediction. Wonderful. This is absolutely amazing. This is what exactly the size of the PCB. Now what I will do, I'll go to the copper pouring. I'll make sure it is a ground one, and I'll start pouring the copper here. Absolutely similar to the previous tutorial, so there is nothing special or nothing different here. It's just like a circuit different actually. Circuit and designator and all those things are different, but the procedure is absolutely similar one. Not similar, exactly the same one in fact, because that's more important, right? So these are the few settings that I will be doing here, and once those settings are completed, I'll make it as a 1 mm clearance so that it is easy for you to understand also. And you can notice all other things are set like this, and once that is done, your entire circuit is ready. I'll check with the design manager once again. Voila. So the ground part is also connected, all the pins are connected. This is absolutely perfect one. Now what is the next step? Of course we need to work on the designator part. Here we have a designator, so I'll just change the designator to one direction, which is absolutely important. And notice here it has been a little bit problem here, so I'll just change it to one specific angle like this way. And then we have a U2, which I'll place it somewhere here. U1 is in the right place, and then we will be having a C1 and C3. Thereafter we will be having a C2, which is again important. Now you can see that the R1 is placed above the resistor, which is absolutely necessary, and then we will be having a R2, which I'll be placing somewhere here. And LED1, LED2 are in a best place, so I'm not going to change them. But P1 and P2 and P3 is something that I need to modify, so I'll be going here and I'll be changing it somewhere from this point to this point and this point to this point. After that, what we need to do is we need to add some indication here, which one is the input and which one is output. So I'll be adding here, which is V in, and I'll be changing the dimension of our text, which is absolutely important, which is sufficient enough. And at the output side, of course, we need to place output here, which is plus 12 volt at this point. I'll be placing it in this direction, and then we will be having a ground here. And similarly, we will be having a plus 5 volt here, and then we will be having a ground also. This is all about the creating your entire circuit. Of course, I am missing with a drill hole point and all, which is optional. If you are interested to add a drill hole point, you can add that one. And of course, there is one more important thing, that is all about adding a name of your company or logo or something like that, if it is necessary and if you feel it is interesting, so you can do that. But in this particular tutorial, I feel it is not necessary for us to go in that particular detail from my side. But from your side, if you are interested, you can literally do that. There is no problem with that. This is how the entire PCB has to be designed, and then we will be looking into a 2D activity so that we can identify if there is any problem with respect to the design of the circuit. So on the top side, all the components are properly placed, and the bottom side, you can see that all the routing is done in a proper way. So this is how we need to inspect the product or inspect the PCB and send it for the review activity. Alright, I believe that you have enjoyed the entire tutorial and you are able to do the circuit as instructed in this video. Of course, if you have any questions or any concerns, then please comment below and ask your questions in the comment section. Consider subscribing to our channel Linked Frequency. Tune yourself to make a difference.